Trinity Demonstration Program 1, where one of the goals is to improve the agility of European SMEs in the manufacturing industry. This use case has been developed by a consortium formed by two SMEs, ARGRIND, ModuleWorks and the research center IDECO. We have worked on a robotic solution with process control to compensate tool wear for accurate grinding, automatic collision-free tool changing, and continuous cloud monitoring. Additional companion software to simulate the ground effect surface to minimize robot programming time. This use case is presented by Trinity SME partner ARGRIND, located at the north of Spain, an area with a strong industrial relevance. ARGRIND is a Spanish SME specialized in the development and commercialization of robotic and industrial automation solutions for the manufacturing industry. ARGRIND has previous experience in the development of robotic systems for finishing of metal parts, specifically deburring robots. ModuleWorks is a German SME and one of the global leaders in simulation software development to enhance CAM software. ModuleWorks wants to increase the range of applications where its simulation capabilities are applied. This use case has provided a challenging opportunity to position ModuleWorks as the reference for simulation of robotic grinding operations with compliant tools. IDECO is a research center specialized in manufacturing and production technologies. IDECO's motivation for the project has been to transfer the technologies developed in previous research projects for the benefit of the European industry and IDECO's future research activities. Robotic solution for accurate grinding of complex metal parts is to move tedious manual grinding operations from humans to robots. This operation has been traditionally made manually by a skilled operator, with all the risk it entails. But grinding a complex metal part is a challenge, and the transfer the precise motions of the humans to the robot is not straightforward. Therefore, to increase productivity, the purpose of this solution is to minimize robot programming time for its new part and zero scrap parts. This project has aimed to complete grinding process of an additive manufactured part from the aerospace sector, as in the video. The main tasks included in this project have been: include a cloud robot and process monitoring, develop a trajectory collision check software, design and manufacture an automatic tool changer system, and develop a ground surface simulation software. The cloud monitoring system captures and stores data from the robot and the process. Additionally, a custom interface is provided to monitor online relevant information. The trajectory collision check software allows the robot to perform movements safely. If the process is paused in a random point of the program, for example to change the abrasive, this software allows to know if the trajectory from that position to a target position is collision-free or not. A full grinding process of a part might need multiple abrasive belts. Therefore, it is of high interest the capability of a robotic cell to change them automatically. For this purpose, a new grinding tool and an abrasive station to take out the worn abrasive and put a new one has been developed. The last task was to perform an overground surface simulation software. Grinding robot trajectories are generated with CAM software, but this software is not developed for these processes, and it does not consider the real geometry and radial compliance motion of the grinding tool. Therefore, the trajectories are generated considering some assumptions, so uncertainties are introduced. This software shows the resulting parts after the grinding process, allowing to make modifications before generating scrap parts. ARGRIND consortium has participated in all the pitching events. 8 organizations have been interested in the demonstration, and the company's production has slightly increased. Less than expected, probably due to the COVID situation. The monitoring every 1 second and 0 scrap parts targets have been achieved. However, due to the complexity of the use case part, programming time has been longer than the target one. The deviation is slightly bigger as the range of the dimensional tolerance was bigger. This demonstration contributes to improve the agility of European manufacturing by providing a turnkey solution for grinding complex metal parts. This task is performed manually by skilled operators, producing physical and mental problems on them. Additionally, manual operations generate part quality fluctuations. The application scenarios for this solution are companies with long manual grinding processes, especially focused on aerostructures, wind energy, or automotive. Thanks to Trinity, we have been provided with essential funding for the development of most important components for this robotic solution. Any company or person interested in the solution presented here can get more information contacting with Aldakin, one of the 3 SMEs of the consortium at aldakin.com, or following us in our social media, Twitter, Instagram, LinkedIn, and Facebook.